Welcome to the another video of Instrumentation and Automation Unit-1, first video. A. Continuous Flow Systems, CFA. Description. These analyzers continuously move samples and reagents through tubing and mixing coils using peristaltic pumps. The reaction mixture flows through a flow cell where analysis, often spectrophotometric, occurs. Features. High throughput and consistent sample handling. Can handle a large number of samples in a short time. Suitable for routine analysis in clinical labs and environmental monitoring. B. Discrete analyzers. Description. Each sample is processed individually in separate reaction vessels or cuvettes. No mixing between samples, ideal for avoiding cross-contamination. Features. Flexibility in testing different parameters. Reduced reagent consumption. Ideal for labs with varying test requests per sample. C. Centrifugal analyzers. Description. Use centrifugal force to mix and move samples and reagents into reaction chambers on a rotating disc. Analysis is often performed via photometric detection as the disc spins. Features. Rapid mixing and reaction times. Compact design and low reagent use. Suitable for small to medium-sized laboratories. D. Thin film analyzers. Description. Utilize dry chemistry technology where reagents are embedded in a thin film or layered on a strip. The sample is applied directly to the film, initiating the chemical reaction. Features. Portable and easy to use. Common in point-of-care testing, e.g., blood glucose meters. Minimal maintenance and calibration needed. E. Automated electrolyte analyzers. Description. Designed to measure electrolytes like Na, K, Cl, Ca superscript 2 using ion-selective electrodes, ISE. Fully automated sample handling, calibration, and analysis. Features. Fast and accurate results. Commonly used in clinical labs for blood, serum, or plasma analysis. Compact and user-friendly interfaces. MCQs. 1. Which analyzer uses continuous sample and reagent flow through tubing? A. Discrete analyzer. B. Centrifugal analyzer. C. Continuous flow system. D. Thin film analyzer. Answer: C. 2. What is a key advantage of discrete analyzers? A. Continuous reagent flow. B. Minimal reagent use. C. High contamination risk. D. Use of centrifugation. Answer: B. 3. Centrifugal analyzers operate based on A. Ion exchange chromatography. B. Centrifugal force. C. Gravity settling. D. Fluid displacement. Answer: B. 4. Thin film analyzers are commonly used in A. Large chemical factories. B. Point-of-care testing. C. Industrial waste monitoring. D. Mining analysis. Answer: B. 5. Ion-selective electrodes are used in A. Discrete analyzers. B. Centrifugal analyzers. C. Automated electrolyte analyzers. D. Thin film systems. Answer: C. 6. In a continuous flow analyzer, mixing of sample and reagents occurs in A. Petri dishes. B. Reaction wells. C. Flow cells. D. Mixing coils. Answer: D. 7. Which analyzer type avoids sample cross-contamination best? A. Continuous flow. B. Discrete analyzer. C. Thin film analyzer. D. Electrolyte analyzer. Answer: B. 8. Centrifugal analyzers are known for A. Using dry reagents. B. Slow throughput. C. Efficient mixing and fast results. D. Manual operation. Answer: C. 9. Which analyzer is most suitable for emergency wards or ambulances? A. Continuous flow. B. Discrete. C. Thin film. D. Centrifugal. Answer, C. 10. Which principle is used by electrolyte analyzers to detect ion concentration? A. Spectrophotometry. B. Ion-selective electrodes. C. Chromatography. D. Fluorometry. Answer, B. 11. Which of the following is a dry chemistry technique? A. Continuous flow system. B. Discrete analyzer. C. Thin film analyzer. D. Electrolyte analyzer. Answer, C. 12. What is the detection method usually used in continuous flow analyzers? A. Flame photometry. B. Ion-selective electrodes. C. Spectrophotometry. D. Manual titration. Answer, C. 13. Discrete analyzers can process samples. A. Continuously. B. All at once. C. One at a time. D. Only in batches. Answer, C. 14. In centrifugal analyzers, which component is rotated? A. Glass tube. B. Flat disc with cuvettes. C. Pipette. D. Reagent bottle. Answer, B. 15. Thin film analyzers are generally used for A. Soil testing. B. Water analysis. C. Clinical diagnosis. D. Air quality monitoring. Answer, C. 16. What is one limitation of continuous flow systems? A. Low throughput. B. Risk of cross-contamination. C. High reagent waste. D. Use of dry reagents. Answer, B. 17. Discrete analyzers are ideal for A. Mass production. B. Small, varied test samples. C. Manual analysis. D. Industrial testing only. Answer, B. 18. Electrolyte analyzers measure ions in A. Urine only. B. Saliva only. C. Blood, plasma, serum. D. Air samples. Answer, C. 19. In centrifugal analyzers, reaction time is usually A. Slow. B. Intermediate. C. Very fast. D. Not controlled. Answer, C. 20. A major advantage of thin film analyzers is A. Complex setup. B. Portability. C. High reagent cost. D. Continuous flow. Answer, B. Thanks for watching. Subscribe the channel if you new here and like, share, comment. Best wishes.